Hello everyone. In the last video, we are discussing about this particular Titanic exercise solution. Now let's continue the discussion. Basically, if you guys remembered, I said skip this particular part. So now let's try to understand what is this. This is a hyperparameter tuning technique, that is grid search cross validation. And let's try to understand how this will work. Basically, you guys might know what are hyperparameters by now. Hyperparameters are the parameters which are adjusted by us. So there are so many hyperparameters in machine learning algorithms. What are the hyperparameters will change from algorithm to algorithm. But mostly you guys might have known about gradient descent, right? In gradient descent, what is the formula? Our formula is theta nu equal to theta old minus alpha times loss with respect to the theta, right? So alpha is one hyperparameter which we need to adjust. I said like you will take this value of alpha from guys who have already experience, and if that particular value is working good for them, then most probably it will be working good for you as well. But all the time it might not work. Then at last, if you don't have any other option, then you need to go for hyperparameter tuning. Okay, one such hyperparameter tuning technique is grid search CV. In grid search CV, we'll try to give some specific values, like let's say we'll write down what are all possible values for alpha, which might be some good values like 0.01, 0.1, and also 1, 10, 100, 0.0001. Like this, you might have several possible values for this alpha, and within all of these values you wanted to find out which is the best value for the problem that we are solving, right? So in that case you can use something like grid search CV. Here, if you observe, we are trying to find some hyperparameter, that is C, which is used in L2 and L1 regularization. If you guys don't know about L2 and L1 regularization, think of this as alpha. And for any hyperparameter, the process is the same. Only thing is that the hyperparameter will change. That's it. Now let's try to concentrate on the concept of this particular grid search CV. If you guys remember, if you are having some data set that is T, which is having, let's say, 1,000 number of points, then I said that we will be dividing it into two parts, that is D-train and D-test. This D-train is the training data that we will show to the model while training, and while testing, we'll use this in order to know how good the model is predicting. This is what we'll do in general, but if you are trying to solve some real-time problem, your dataset will get divided into three parts. One is D-train, and the other one is D-validation, and then we'll be having a D-test. So till now, I only said like we'll be dividing it into training and testing, and while training we'll be using this, and while testing we'll be using this. But in general, what is the process that we'll follow? First, we'll build some model using training data, and after building the model, we'll test it with D-test, and if it is working fine, then it is good. We'll deploy the model. If it is not working fine, then what we'll do? We'll go to the model and we'll adjust the hyperparameters so that it will work good for this d-test, right? But in that case, we are exposing our d-test to the model in some direct or indirect way. So that's why we cannot call this as testing data. So whenever you are exposing the testing data to the model, it is not a good thing, right? The model will have some information about the testing data, and obviously we can't say in future it will work or not. So that's why we should actually divide the data into three parts, and each part will work in this manner. First, you will train the model using dtrain, and after training this model, then you will use this as the testing data, that is the validation data as the testing data. And then if it is working fine, then you can go and deploy, or then you can go and check it on testing data and then deploy. And if it is not working fine, then you will adjust the model according to this validation data. That means you will change some hyperparameters and then do some retraining. Okay, this is what we'll follow in general. In that case, what will happen? We'll use dtrain, and while adjusting hyperparameters, you will use validation dataset. And this validation dataset might be exposed to the model, but as we are having the training dataset separate, if it is working good on the training dataset, then obviously we expect that it will work good on the future points as well. So this is the concept of validation data. So whenever you're trying to solve some real-time problems, it is really very important to use this validation data. Okay. What is validation data? Simply, I'll write down over here. Data used for adjusting the hyperparameters. I hope you guys understood what is this validation data. Now let's try to understand in case of grid search CV how this is happening. Whenever we pass our model to grid search CV, what it will do is it will have training data, right? Let's say in dtrain we are having 1,000 number of points, and in grid search CV, if you guys remembered, we are passing some parameter that is CV equal to 5. So here CV equal to 5. So what it will do, it will divide this training data into 5 parts. So D1, D2, D3, D4 and D5. Like that, some random 200 points will be kept in D1 from this 1000, and after removing 200 points, it will be left with 800, right? From this 800, we'll be placing some random 200 in D2, and then we'll be left with 600. From this 600, we'll place random 200 in D3, and then followed by random 200 in D4 and random 200 in D5. Like that, it will go to 0. Like that, we'll create some 5 data sets, and using these 5 data sets, we'll try to find out what is the best alpha value. So as I said, if you guys remember here in this particular grid search CV, we are saying that these might be our possible values, right? We'll try to search what is the best value among all of these. So in order to do that, let's say we are trying to find whether this is good or not. So what is the process that we'll do is, first we'll take alpha equal to 0.01. Once we took this alpha as 0.01, then our dtrain will be combination of D1 and D2, D3 and D4. So all these 4 sub data sets, or all these 4 parts of the original data that we are having, will be used as training data. Let's say the model that we have built using these as training data is M1. So in order to test how good M1 is, we'll use the testing data as D5. Basically here, this is not testing data. You can think of it as validation data. Validation data will be the correct term because we are trying to adjust alpha, right? So that's why this, you can think of it as validation data. And using these 4 points, we are building a model and we are checking how good the model is with the help of D5. And let's say the accuracy that we are getting is some A1. So on this data, we are getting an accuracy of A1. And similarly, next time what we'll do, we'll try to place D4 over here in the validation data, and remaining points D1, D2, D3 and D5, these will be taken as inputs, whereas this part will be taken as the 5th part. And finally on this validation data, the accuracy is, let's say, A2. This is model 2, which is built on these 4 points, or these 4 as the training data. And later we will build another model that is built on D1, D2, D4 and D5. And now D3 will be my validation data, and the accuracy is, let's say, A3. Like that, we'll build 5 different models. Next, we'll use D1, D3, D4 and D5, and D2 will be my validation data, and A4 will be the accuracy, let's say. And this is the M3 model which is built on this data, M4 model which is built on this data, and similarly M5 model where the training data will be D2, D3, D4 and D5. And here my validation will be D1. And we'll be getting an accuracy of A5. Now we can do some strategy like averaging all of this. So let's say this is A average. And what is this average accuracy for? This average accuracy is for value alpha. So basically in all these cases, we are fixing the alpha to be 0.01. Okay. So we are fixing our hyperparameter alpha to be 0.01, and then we are training the model that we are having. So this M1 model is having alpha of 0.01. This M2 is also having an alpha of 0.01. M3 is also having an alpha of 0.01. M4 is also having alpha of 0.01. M5 is also having alpha of 0.01. And then we are getting an average accuracy of this much, A average. Now, you need to find the best alpha, right? For getting this A average, on this alpha, you are running model for 5 times. Remember this. Now we'll run the same process for the next alpha. What is the next alpha? Next alpha is 0.1. So we'll change this to 0.1 and we'll repeat the same process. We'll build 5 different models with alpha as 0.1 and we will get another A average for the second alpha. So first alpha is 0.01. Here the alpha will be 0.1. Like that, we'll get several A averages for each and every corresponding alpha. And in each case, what we'll be doing, we'll be building 5 different models. Okay. So like that, we'll get all the A averages. If A average is high, that means that the corresponding alpha value is working good for us. That is what it is implying, right? Let's say among all of these, among all the A averages that we got, let's say this particular A average value is some 95% and it is the highest, let's say. So for this, the average is the highest and it is 95%. Then we'll fix our alpha value to be 0.01. So this is what we'll be doing in grid search cross validation. I hope the concept is clear. Now let's try to see the code, what is happening over there. So here, instead of alpha, we are having some other hyperparameter that is C. And these are the possible values for C that we are writing over here. And then we are mentioning CV equal to 5, which means like this, it got divided into 5 parts. If you are giving 6, then it will get divided into 6 parts. Okay. Then you need to build 6 models for each alpha or each C value. Okay. And then after that, while fitting, after fitting it, you can check what is the estimator, best estimator. So our best value for C is 1 in this case. Okay. In your case, it can be some other thing. If you're building some other model, then it can be something like 10. And in some other time, it can be 100. Okay. So like that, we'll be getting our best estimator or best hyperparameter value through this grid search CV. I hope this concept is clear for everyone. And if you have any doubts, please comment down in the comment section. Thank you everyone. Bye bye.